All right, so where we left off is you were brainstorming these two numbers, and you should have come up with 6 and -3, because 6 times -3 is -18, and 6 plus -3 is +3. So now we have our two numbers. So those of you doing the box method, you're going to put the first term in the first box, last term in the last box, and we're splitting this 3x up into 6x and -3x from the numbers that we just brainstormed. If you're doing grouping, you're listing those four same terms out. Now we're looking for the GCF. The GCF of this row is just x, and the GCF of this row is x. X times x is x squared. X times what gives me 6x? X times what gives me -3x? And -3 times 6 is -18. So we have found our factors. They are x minus 3 and x plus 6. X minus 3 and x plus 6. So therefore, our solutions, if we set our factors equal to 0 and solve for x, I'm going to add 3 on this one. So one solution is 3. I'm going to subtract 6 here. And the other solution is -6. All right, I'm going to do grouping on the next one, but if you are enjoying doing the box, continue that method. Like I said, today I just really want you to choose the method that's working for you. Now, one thing I didn't do on this problem, I really skipped asking, is there a GCF? And you always, always, always want to ask that question first. So let's begin by asking this one. Is there a GCF? Is there something I can divide all three of these by first before I begin factoring? All of these are divisible by 5. So I first need to do that step. So I'm going to divide everything by 5. Now I'm going to factor just what is remaining inside of the parentheses. I'm going to ignore the 5. It's going to be one of my factors, but I am not going to use this anymore for the rest of the problem, okay? So now either you're using the 4 terms here, the 3 terms here to brainstorm, or you're doing grouping. So let's brainstorm our two numbers. It's going to multiply to -4. 1 times -4. That's the A times C. And it's got to add to the B, which is -3. So take a minute and brainstorm what multiplies up to 4. Now I'm looking for the combo that is going to add to -3. Well, if I make the 4 negative plus 1, that will give me -3. All right, again, I'm ignoring the 5. I'm doing grouping here. So I'm dropping down the first term. I'm splitting the -3x into -4x and 1x, and then I drop the last term down. So the first and last drop down. This is being split up from those two numbers we just found. All right, so I'm looking for the GCF of the first two terms, which is just x. I'm looking for the GCF of the second two, and this one's just 1. Nothing else will divide into them. Notice my parentheses match. They have to match sign and everything in order for it to be factorable. And so one factor is going to be x minus 4, that matching parentheses. The other factor is going to be x plus 1. What's on the outside of those parentheses. Now, for my solutions, I'm going to set each factor equal to 0. When I set 5 equal to 0, that makes no sense. There's no x for me to solve for here. So this just means that does not give me another solution. But I'm going to set x plus 1 equal to 0, and that will give me a solution of -1. I'm going to set x minus 4 equal to 0, and that will give me a solution of 4. All right, I would like you to try the next one on your own. You're going to choose which method you like best. Before you begin, though, always make sure that your equation is equal to 0, because the 0 product property only works when it's set equal to 0. Because remember, we're trying to find where does it cross the x-axis, and that is when y is 0. So we want it to be equal to 0. So first step is I'm going to subtract 8 to get it equal to 0. And then, of course, I'm going to look for a GCF. Is there something that I can divide all three of these by first. There should be nothing, okay? So there's nothing that will divide into all of them, so we can go to the next step. We are now brainstorming two numbers that multiply to, be careful, a times c is negative 24 and adds to negative 8. Okay, pause the video here and go ahead and finish this problem and we'll see how you did. Okay, let's see how you did at brainstorming. The correct answer is negative 12 and 2 for those two magic numbers. Did anybody choose negative 6 and negative 4? They do add to negative 10. So how do I know which one to choose? Think carefully about this. Remember, it has to multiply to negative 24 and add to negative 10. What is negative 6 times negative 4? That's positive 24. So be careful. If you accidentally chose negative 6 and negative 4, notice it does not work whenever you do the multiplication step. The only one that works for both of them is 2 times negative 12 is negative 24. 2 plus negative 12 is negative 10. So be very careful that you check your numbers because there's only going to be one number or one pair of numbers that's going to work. All right, go ahead now and finish solving. I'm going to do grouping again for this one. If you switched around these two middle numbers, don't worry, we're going to end up in the same place, okay? It doesn't matter which order you put these two terms in, just like it doesn't matter when you're doing the box which two order these are in, okay? You can switch those up. We'll end up in the same place. All right, I got the factors 3x plus 2 and x minus 4. I'm going to set both of those factors equal to 0. So one solution is going to be negative 2/3, and the other one will be positive 4. Very good. All right, I'm going to start you off on the last problem, and then I'm going to have you work with your teammates on the rest to see if you can figure out how to factor them. Notice it is equal to 0 on this one, so we're good to go on that. And the next thing I'm asking myself is there a GCF? Is there something that I can divide by all of those? Well, I recognize they are all divisible by 2. And look at the x's. They all have at least one x also. So the GCF here, the greatest common factor, is 2x. Now I'm going to divide all three of them by 2x. You should be able to check by multiplying it back out. 2x times x squared is 2x cubed. 2x times negative 6 is negative 12x squared. 2x times 9 is 18x. So it should multiply it back out to the original problem. Okay, now I'm going to ignore my GCF. It is going to be one of my factors, but I am going to factor what is in the middle, in the parentheses here, to finish off. So you should be brainstorming two numbers that multiply to 9. 1 times 9. Notice I'm not looking at the GCF when I'm looking for what it has to multiply up to. This is the 1 times 9 is 9. And add to the negative 6. Go ahead and brainstorm those two numbers. And you should have got negative 3 and negative 3. Okay, either do your grouping or your box. If you're doing the box, the first term goes in the first box, last term in the last box, and the negative 6x is going to be split up into negative 3x and negative 3x, the two numbers we brainstorm over here from the x. Okay, looking for the GCF. I find it when you're doing the box to always start in this corner. It's the easiest place to begin. X times x is x squared, so this one's a pretty easy one. And I got x minus 3 for both factors. So my factors are the GCF of 2x times x minus 3 times x minus 3. Or you could write this as 2x times x minus 3 squared, since they're the same thing. I could simplify it that way. So when I find my solutions, I'm going to set both factors equal to 0. This one is going to produce x equals 3. It's going to produce it 2 times, but I don't need to write it twice. What happens when I set 2x equal to 0? Can I solve for x? Sure. I'm going to divide by 2. 0 divided by 2 is 0. So we have 2 solutions here. One solution is 0 and one is 3. All right, with your group, I would like you to try the other 5 problems, practicing your factoring, and then go put one solution on the board that your team has figured out so that we can conquer our factoring. This takes practice, so be sure you do all the homework. This is going to be an important skill for you to practice. So be sure that you're practicing your factoring, and because the more you do it, the better you get. All right, good luck, guys.